Real quick on your green worksheet, something I should have mentioned on Thursday, you can skip numbers 15 through 18. You do not need to try 15 through 18. They talk about if the triangle is acute, obtuse, or right. That's not something we're going to do in class. If you're interested in finding out about 15 through 18 and how do you tell if the triangle is acute, obtuse, or right, what does it even mean for a triangle to be acute or obtuse, we can talk about that in class, or you could do your own YouTube or Google or Khan Academy search for that. But for right now, just know on the green worksheet you can skip 15 through 18. Okay, here we go with green worksheet that most of you got on Thursday, the Pythagorean theorem and its converse. We'll do a few examples here, so hopefully you can get the hang of this. So I'm going to go over, I think, about 5 problems here. I'm going to start with number 1. If you see, I have it up on the screen 3 times, and there's a reason for that, because I'm going to show you kind of 3 different ways you could set this up. So we're going to start with probably the traditional first method that most people use, and that is using the formula. Remember, I want you to start with the formula here. Formula for the Pythagorean theorem is a squared plus b squared equals c squared. Now I'm actually going to have that on the first 2 triangles, a squared plus b squared equals c squared. And then the way that I actually like to do the formula is instead leg squared plus leg squared equals hypotenuse squared, or leg squared plus leg squared equals hip squared. Okay, it's all going to come out to the same answer, but you kind of get to pick which one you want to use here. Okay. So first off, if I start with a squared plus b squared equals c squared, I might call this side over here, that might be a, and this side might be b, and the thing to remember is c is always the hypotenuse. So if you remember, the hypotenuse always goes opposite the 90-degree angle. So there's our 90-degree angle right here. If you go opposite that 90-degree angle, that would be c in a squared plus b squared equals c squared. Same thing for the second example we'll do. This would also be c when we talk about a, b, and c. So number 1, I could call 12 the value for a, b can be x, or leave it as b if you want, and 13 would be the value for c. So when I come here to my formula, so I'm going to plug in, I'm going to put in a 12 for a. So I'm just substituting, taking a out, putting in 12. I'm still squaring it though, because that's part of the formula. I still have addition as part of the formula. Now I could either leave b as b, the variable b, or here I might change it to x. I'm going to change it to x. Okay, so b gets replaced with x, but I'm still squaring it as part of the formula. And then it still is equal to c squared, so it still equals, but now for c, I can take out c and I can put in 13 for c. So c gets taken out, and 13 is put in its place. Okay, so that would be the substitution step, replacing some of the variables, in this case actually all of them, but a was replaced with 12, c was replaced with 13, b, again, you could have left as b, or you could put in x, since they use x. Now I'll finish solving this, but before I do that, I'm going to show you the setup for two more ways here. So second setup, again, using a squared plus b squared equals c squared. Again, c has to be the 13. And if you remember, if I come over here to the leg squared plus leg squared, 12 and x are actually the legs. So 12 is a leg and x is a leg, and 13 is the hypotenuse. So, but which one, if you use a and b for your legs, you could say, oh, I wanted to call x, to call that my a, and 12 to call that the b, and that's fine. That works because these are being added, and we can switch the order of addition. So here, for a, I might, again, leave it as a, or I might say, well, we're using x for a, so I'm going to do that. I'm going to put in an x for a, still squaring it, it's part of the formula. Still adding as part of the formula. Now b for this one is 12, so b would get replaced with 12, but we're still squaring it. Oops, let's try that again. We're still squaring it, and we still have it equal as part of the formula, and then c again is 13, and we're still squaring it. Okay. So 12 squared plus x squared equals 13 squared. Here it's x squared plus 12 squared. And again, when you're adding, it doesn't matter if it's 12 squared plus x squared plus 12 squared. It's the same thing. Okay? And then the last way that I like to do leg squared plus leg squared equals hip squared. It doesn't matter which leg you put first, just like we saw with these 12 squared plus x squared or x squared plus 12 squared. So I'll start with the first leg. I'll put in x for that, and I'm squaring it, plus the other leg, which is 12 being squared, is equal to the hypotenuse, which is 13 being squared. Okay. So it doesn't matter if you do a squared plus b squared is c squared, or leg squared plus leg squared equals hip squared, and which one you call a and b, or which leg you do first. You should have one of these three. Actually, the first one and the last, or excuse me, the second and the third one are the same, but you should have one of these as your setup there. Okay. Now from here, I'm just going to finish with one of them because the rest of them they're all the same. But I'll pick this one in the middle here. So now we're doing a little bit of algebra. So as I come across this, I go, okay, x squared, right now I can't do anything with x squared. At some point I'm going to want to cancel that square, and we'll talk about how to do that if you forgot. But what could I do? Ooh, I can do 12 squared. I can do that. 12 squared is 144. So this can become 144. I can do 13 squared. That's 169, I believe. Okay. And let's rewrite that, 169. Now I still have the equal sign in between, and it's very important that I don't lose that equal sign. I still have x squared and I'm still adding, so it's very important that I don't lose that. Okay. And again, the other two equations, if you do those, these should all pretty much look the same. Now if you remember, if I can get it to x squared equals a number, then there's a way for me to cancel that square. But right now I don't have x squared equals a number. I have x squared. I've got this plus 144 that I don't want there. So I can cancel adding 144 by subtracting 144. So that these will cancel. If you add 144 and subtract 144, they cancel each other. It's like if I give you $144, but then I take $144 away, it's like I didn't even do anything, and you're back to your x squared. But now if you remember, this equation is a balance, so if I change the left side, I have to change the right side the same way. So I have to also subtract 144 from the right side so that I keep them balanced. Okay? And when I do that, 169 minus 144 is 25. But I'm not done yet. Remember, we want to solve for x. We want to say what x equals. So, but I'm close. So if you remember, the way to cancel a square, and I'll type this out here, we cancel a square, and that is an exponent of 2, by using a square root. And so very important that we remember that. Let's see here. Cancel a square, an exponent of 2, by using a square root. So if I do the square root of x squared, that will give me x. But again, this is an equation. I change one side, I have to change the other side the same way. So I have to do the square root of 25. And if I know that, great. If not, I can do that on my calculator. But that gives me 5. And that is my answer. So x equals 5. And remember, you can get that answer. You can think, is this reasonable? Is my answer reasonable? Always a good thing to think about. Is my answer reasonable? Well, in this case, it's a leg. The hypotenuse is supposed to be the longest side, so it should be less than 13. And it is less than 13, so I'm fairly confident that at least it's reasonable. It's possible I'm still making a mistake, but my answer is reasonable. So here we go with number 2. So again, we're looking at a right triangle. We've got the 90-degree angle here. We know two sides, looking for a missing side, so I can use Pythagorean theorem for this. So whether I want to do a squared plus b squared equals c squared, or I want to do leg squared plus leg squared equals hip squared. Either way it should work out. And when I look on here, again, the way I like it, I prefer the leg squared plus leg squared is hip squared. Remember, the legs make the right angle. So there's the right angle. These are the legs that I'm tracing. So 4 would be one leg, and 3 would be the other leg. X is opposite from the 90-degree angle, so that is the hypotenuse. If you're doing a squared plus b squared equals c squared, the only important thing is that the hypotenuse is c. 4 and 3, it doesn't matter which one you call A, which one you call B. You could say 4 is A and 3 is B, or you could say 4 is B and 3 is A. It should come out to be the same thing. So when I plug this in, I'm either going to have a squared plus b squared, 4 squared plus 3 squared, or 3 squared plus 4 squared, same thing, equals the hypotenuse squared, and the hypotenuse is x, or again, you could put in a c if you want to. Doesn't matter, but we are squaring that. Okay, so all of these are being squared. 4 squared, 3 squared, x squared. We've got the addition between the 4 and the 3, the 4 squared and the 3 squared, equal to x squared or equal to c squared. So that's the substitution step, putting those things into your formula. Next comes the algebra. How do we solve this? So if you remember, we want to simplify first. We want to do the things we can do. I can do 4 squared. I know what 4 squared is, or I can use my calculator to get that. That is 16, 4 times 4. I can do 3 squared. I know what that is, or I can do it on my calculator. 3 squared would be 9. X squared I am currently stuck with, and again, we will eventually cancel that square, but not yet. First, we want to simplify this side over here as much as we can. So we're going to stick with the x squared. We're going to wait patiently until we're ready to cancel that when everything is simplified on the other side. We still have the addition here in between, and we still have the equal sign in between there. Okay, so we just simplified. 4 squared is 16, 3 squared is 9. That's all that changed now. Still have the addition, still have equals, still have x squared. I can still simplify this now. I can do 16 plus 9. 16 plus 9 would give me 25. Okay, the equation says to add them, 16 plus 9. Not like last time. Last time, what did we have? We had something like x squared plus 144 equals 169. We're not supposed to add the 144 and the 169. The equation does not say that. The equation says it's x squared plus 144. But here we are adding. The equation does say 16 plus 9. So I go, all right, let's go ahead and do that. 16 plus 9 is 25. Still equals x squared. Yeah. So this one is actually turning out to be easier, at least in my opinion, than number 1 was, because I didn't have to cancel it. Like over here I had to cancel the plus 144. Here there's nothing to cancel. It's just do the addition, 16 plus 9. So now I've got it down to 25 equals x squared. There's no more simplifying I can do. I can't do anything else with 25. So now comes the time where I'm going to cancel that square, the exponent of 2, by using a square root. Okay, that's what we're doing now. So I can do the square root of x squared, and that will give me x. But remember, it's an equation, so you have to treat the other side the same. And we saw this last time. It was the square root of 25. So again, we get 5. And that is a coincidence that we got the same answer in the first 2 problems. And then again, a good idea, especially in geometry, is to think to yourself, is my answer reasonable? We're solving for the hypotenuse. So the hypotenuse should be the longest side. We should get something more than 3 and more than 4, which really means more than 4, and 5 is more than 4. So it's reasonable. Again, it's possible we're making a mistake, but if we had gotten maybe something like 2 or 2.7, I go, 2.7 wouldn't be reasonable because it's less than 4, it's less than 3. So at least it's reasonable, and if you trust me, it is correct. Number 5, I'm just going to mention real quick. I'm not going to go through the whole thing, but the instructions might be a little confusing. Number 5 and 6 say, the instructions say, find the missing side of each triangle. Here's the confusing part maybe. Leave your answers in simplest radical form. So simplest radical form is something that we actually study in Geometry B, but we're not going to worry about it here. For now, for 5 and 6, what I want you to do is the same thing as 1 through 4. Solve for the missing side, solve for x, but round your final answer to the nearest tenth if necessary. So don't worry about that simplest radical form, just do like you did on 1 through 4. For number 8, same thing with the instructions here on number 8. As far as they say this, leave your answers in simplest radical form. Don't worry about that again. We're going to again do like we did on 1 through 4, and then again on 5 and 6. We're going to round our answers to the nearest tenth if necessary. So don't worry about this whole weird thing. Just do like you've been doing before. But when we look at number 7 and number 8, what I notice that's different about these is that they don't give me a picture. They don't draw a triangle for me and show me the side lengths. So instead what they do is they tell me B equals a number and C equals a number. Or on number 7 they say A equals a number and C equals a number. But now they do specify here, they tell us that C is the hypotenuse, which is, I like that. That's why I like leg squared plus leg squared equals hip squared, because otherwise I feel like I have to specify this side C is the hypotenuse. So what I can do here to make this look like 1 through 6 basically is I can draw my own picture, and we're drawing a right triangle. Okay. So they say find the missing side of each right triangle. So we do have a right triangle here. So I can draw myself a right triangle. They say C is the hypotenuse, so I can label that as 4, and I'm not worried about the units, the yards. Now, something else that makes this one a little tricky, number 8 especially, is this whole square root of 6. They give us a side that's the square root. That's what we're talking about there, if you remember. That's the square root of 6. And we'll see, by the way, this is probably more difficult than anything you'll have on the test, but the square root of 6, that's one of my legs, so it doesn't matter which leg it is, but the square root of 6. And then the other side, you can call it A, I suppose, because this is supposed to be B, so that third side, that other leg, you could call A. Let's make that a little bit nicer. Or you could call it X, whatever you want to label it there. Okay, but we're solving for the missing side. One thing that's important to understand, when you look at this and you say, okay, so we've got opposite the 90-degree angle, 4 would be the hypotenuse, and again, that's what they told us. They called it C, and they said C is the hypotenuse. B is the square root of 6, and B would be a leg if C is the hypotenuse, and then A would be the other leg. Is some of you might be looking at this and go, whoa, I thought the hypotenuse was supposed to be the longest side, but it's 4, and I see a 6 on the leg. And what I want you to make sure you understand is that it's not 6, it's the square root of 6. Okay, that is different than 6. So if I do on my calculator, if I do the square root of 6, this looks a little bit different on my calculator here than it does on yours. But if I do the square root of 6, I get 2.449, a little over 2.4. So what you might think about is the square root of 6 is approximately 2.4, but I'm not going to use 2.4 in my formula. I just want to show you that it's not 6, it's the square root of 6. It comes out to about 2.4, so it is less than the hypotenuse. Hypotenuse is 4, square root of 6 is about 2.4. Okay? I'm still going to use the square root of 6 in my formula. Okay, so here I go. So again, whether I use leg squared plus leg squared equals hip squared or A squared plus B squared equals C squared, it's essentially going to come out to A squared plus the square root of 6 squared equals 4 squared. So again, notice I'm not using the 2.4 because it's not 2.4, it's close to 2.4. I don't like using rounded numbers in my work. I like to save my rounding for the end if I need. Okay, so A squared plus the square root of 6 squared equals 4 squared. So again, we want to simplify here. X squared is just going to hang out because A squared in this case. A squared is just going to hang out, and the plus is going to wait, and the equals is going to wait. oops, 4 squared is equal to 16. That one's not too tricky. The square root of 6 squared, though, that one might be a little more difficult. So here's, I'll do it one more time for you here, but so 6, doing the square root of that, and then if you square that, oh, it gets you back to 6. Isn't that interesting? And I can do that on the calculator. I can do the square root of 6, leave that on the calculator, and then square the result. But if I want to work smarter instead of harder, you might remember that we said a square root cancels a square, and it works the other way too. A square, an exponent of 2, cancels a square root. They are opposites. So when you have both of them together, they go away. So we're just left with the 6. So this becomes a squared plus 6 equals 16. And now I gotta finish up now. There's no more simplifying to do. I'm not going to combine the 6 and the 16 as they are. I'm supposed to do a squared plus 6. But remember, my goal is to get a squared equals a number. So a squared equals something. Okay, so I got to get rid of this plus 6. I got to cancel that. What cancels a plus 6? A minus 6. Plus 6 and minus 6 cancel, but whoops, I got to balance. I got to do the same thing on the other side, so I have to subtract 6 on the other side. 16 minus 6 would give me 10. Okay, so we get a squared equals 10. And now, as we've said a few times, but I don't want you to forget, how do I get rid of that square on the a? How do I go from a squared to a? How do I cancel a square, an exponent of 2? I use a square root. So now I'm going to do the square root of a squared, which will give me a, but balance the equation, do the same thing on the other side, square root of 10, and this is where my calculator is going to come in handy, because the square root of 10 is not a nice result. Okay, so if I do the square root of 10, I get 3.162277. It keeps going, and this is where rounding will come in. So we got, let me just jot this down, 3.162, it keeps going, 3.162 ... Our instructions here, we said we're not going to do the whole leave your answer in simplest radical form. We're going to round to the nearest tenth. So rounding, I've got a 1 in the tenths place with a 6 next door. 5 or more raise the score. So this becomes, should be a is approximately, take that out, a is approximately 3.2. There's my answer, and once again, as I always want you to do for these geometry problems, ask yourself the question, once you get your answer, is my answer reasonable? If this was a leg, it should be smaller than the hypotenuse. Hypotenuse was 4, so it is a reasonable answer. Okay, so here's number 9. This is the last problem I'm going to go over for this video. But number 9 asks if we have a right triangle. If you notice, we've talked about this in class. There is no 90-degree angle. There is no right angle marked. Some people would say, well, it looks like it's a 90-degree angle. It looks like a right angle. And if you remember me, I say, don't go off of how it looks. But they want us to state if each triangle is a right triangle. So this is where we come to what's called the converse of the Pythagorean theorem. I don't know if you noticed that. At the top of the worksheet it says the Pythagorean theorem and its converse. And I'll explain to you what a converse is here. But just to remind you, the Pythagorean theorem says if you have a right triangle, if we start with a right triangle, then the leg squared plus the other leg squared equals the hypotenuse squared. The one leg squared plus the other leg squared is the hypotenuse squared. The converse of that is when you switch the if and the then. You switch the statements that come after if and then. So that would be this. The converse says if your leg squared plus the other leg squared equals the hypotenuse squared, then you have a right triangle. Okay, so it works backwards, and we have to be careful about doing this, and hopefully I think we'll talk about this in class on Tuesday when I get back, but a converse is not always true in general, and you'll probably hear me talk about in class. If I say something like, if I am in Bloomington, then I am in Minnesota. And we're assuming we're talking about Bloomington, Minnesota. There's a lot of Bloomingtons in the United States, but if I'm in Bloomington, if I'm at Metro South, then I'm in Minnesota. But if I do what's called the converse of that, and I switch my if and then statements, if I am in Minnesota, then I am in Bloomington. That is not necessarily true, because I could be in Minnesota and be somewhere else besides Bloomington. So this first one is true, the original statement is true, but what's called the converse does not have to be true. However, it is true. The converse of the Pythagorean theorem is true. Okay, so in general it doesn't always work, but the converse of the Pythagorean theorem is true. And again, I'll try and explain that a little bit more in class on Tuesday when I get back. But right now, one thing I just want to mention real quick, we probably shouldn't say for the converse if leg squared plus leg squared equals hip squared or hypotenuse squared, because if we don't know it's a right triangle, then we can't call it the hypotenuse. So we should probably say, here we should probably say a short side squared and another short side squared, and then what would be the hypotenuse. For all we know, it's just the long side or the big side. That's really what we should say. But I'm not going to worry too much about that here. Basically, what we're going to do is we're going to try these numbers out in the Pythagorean theorem and see if they work. And if they work, then we go, all right, it worked. We've got a right triangle. And if they don't work, then we say, then we don't have a right triangle. So to do this work now, when I come to these numbers here, again, it really should be this one short side squared plus the other short side squared equals the long side squared. That's what we're going to check. We're going to see if that's true. If the two shorter sides, the squares, the sum of their squares is equal to the long side squared. So 15 is my long side here. So if it is a right triangle, this would be the hypotenuse. And I'll usually talk about this as the potential hypotenuse. I don't know what's the hypotenuse because we only have a hypotenuse if it's a right triangle. But it would be the hypotenuse if it is. 9 is one short side, so that's a potential leg. I'm going to put question marks by these because I don't know if they're legs and hypotenuse unless I know it's a right triangle. 12 is another short side, so that maybe is another leg. Okay, so I'm going to plug these in. Use my formula. So we're going to check here with the to see if these numbers would work in the Pythagorean theorem. So my potential leg squared, one potential leg squared plus the other potential leg squared, does that equal the hypotenuse squared? And so I'll put my numbers in here. One potential leg squared was 12 squared plus the other potential leg, 9 being squared, and the potential hypotenuse was 15, and we're squaring that. And this is where I like to put a question mark over the equal sign. Not that you need this, but it's like I'm asking a question. 12 squared plus 9 squared. Does that equal 15 squared? That's what I'm going to check here. So one nice thing about this is that if you notice there's no variable here. It's all numbers and operations. So I can split up the left side and the right side, and I can just do the operations and check to see does the left side give me the same result as the right side. So 12 squared would be 144, plus 9 squared would be 81, and 15 squared I think is 225, but I'm going to double check here. 15 squared, yep, is 225. So we get 225 here. So I'm still asking, like, 144 plus 81, is that equal to 225? So then I can add these two together, 144 plus 81. And that gives me 225. And I still have, I'm just going to bring this down on the other side. Is that true? Is 225 equal to 225? Yes, it is. So state if each triangle is a right triangle. My answer here is I would say it is a right triangle. Yes, it is a right triangle. And I could specify I want hypotenuse is 15. Hypotenuse is 15 meters. Okay. Just so it's clear, it is a right triangle. So that's all you're going to do when you're checking 10, 11, and 12. State if it's a right triangle. Try it out. Put the numbers into the Pythagorean theorem. See if they work. If the left side does equal the right side, then you say yes, it is a right triangle. If we would have gotten something like, if we would have changed this right here to a 16. So I said, oh, it wasn't 15 squared, it was 16 squared. So it wouldn't be 225. I think that's 256 now. 16 squared is 256. So that would be 256. And then I would say, no, 225 on the left does not equal 256 on the right. So then my answer would be no, it's not a right triangle. So put those numbers into the Pythagorean theorem. If the left side winds up equal to the right side, it's a right triangle. If they wind up, the left side and the right side are different, you get something like 225 equals 256, excuse me, then it is not a right triangle. So I hope this was helpful to you. You can go back, rewatch this video, and I will see you folks soon.